Well, in the last lecture, we talked about Java threads, and we have seen that how threads can help in uh, supporting parallel execution of some tasks. Now, in this lecture, which what we'll do, we'll concentrate on the implementation of the client server using communication with the help of Java. And if you recall earlier that when we talked about client server communication, we said there are two types of communication possible. One is which we call the connection oriented protocol, in which server opens a socket and binds it to the socket and then listens to the socket. When similarly client also opens socket, connects to it, and when it then listens to the socket and tries to check whether client is communicating to it. Until then, the server program remains blocked, and once the connection with the server, that is the client, starts its communication, then it receives a request from the client, and after that it sends the result, it processes it and then sends the result back to the client. Now what we will do, we'll see that how with the help of Java threads, what we can do, we can allow the server to listen to multiple clients and also do the processing. That is the part in which it when after receiving a request from the client, it has to do certain processing to send the result back, and this job can be done in a different threads, so that the server now will be free to listen to the socket again to if there is another client wants to communicate to it. Now this kind of implementation is possible in Java, but before trying to see the communication in the Java environment, what we will do, will see that Java itself, the language itself, supports the concept of socket. So the socket concept is also there, and and what are the types of methods that are supported in a socket class. So to begin with, therefore, the Java sockets in a Java environment, a socket is basically used for inter-process communication channel, and once connected, processes, in this case will be the threads, can read or write through such communication channel. That's a formal definition of a socket. So therefore, once we create a socket, like in the previous example, in this case, the diagram, in this case server, and both the server and the client essentially communicates through the same socket. Whenever the client wants to send a request, it sends to the server, server listens to the socket, receives the request, and after processing it sends back the result through the socket to the client. So therefore, the concept of the socket is very useful in implementing some client server communication. And in Java there is a class called sockets, and which is defined in the package called java.net package. Now there are two types of sockets which are available in Java, and we'll talk about both. One we call the TCP IP socket, another is called the datagram oriented datagram sockets. Each TCP IP socket, this name, the TCP IP, is related to the well-known TCP IP protocol, which is used in the in the internet also, and essentially the TCP part, which works at the transport level, is a transport level protocol. What it does, it ensures the reliable delivery of the packet from one source to the destination. And IP, which is called Internet Protocol, is very well known and is used extensively in the internet domain. And according to this protocol, we will see that we'll have to the different machines which are connected to the network will have an IP address, which is normally specified in a 32-bit, which is a 32-bit address, and the address is specified like this. Say for instance, an address will be of this type, say 144 dot 16 dot say 192 dot say 63, in which case each of these 4 bytes, sorry 1 byte indicate that is the total address is 32 bit, and this is divided into 4 fields, and there are different types of IP addressing available, and these are called class A, class B and class C. So each network and so on. So this will be is covered in a networking course in detail. What happens in case of an IP address? So an IP address will be, this is an IP address. IP address is a 32-bit long address which identifies the address of a machine connected in the network. Alternately, the address, as we will see later on, an address also can be specified with the help of a name, and then there is a domain name server which translates the logical name of the machine to its physical address, which is like this. So for instance, we can write an address, we have seen that yahoo.com, or we have a machine name like in Kharagpur, we write iitkgp.rnet.in. So this is, which indicates that this is this com will indicate, this field indicates this is the company. Here this field indicates this is the country code. This is some group code called ERNet, is under the ERNet project, and then IIT KGP is a machine in Kharagpur, which is the main machine which is received, which is the server in our environment. Similarly, we have let us say MIT.edu, which indicates that this is a Massachusetts Institute of Technology in US, and edu is an education, this is an educational institution. So these things have been discussed in your network course. So what we will see later on, that Java supports both the address to be specified like a full addressing, like it's a 144.16.192.63, indicating the 32-bit address for the specific machine, or it can be specified in this format, in which there is what we call the domain name server, which is used to translate the physical address, this machine's address, into something physical address, which will automatically done this kind of addresses, and then communication will be established. Say for instance, server is running in this machine, we have a client in another machine. So the communication, in order to these to communicate, we must have the address of both the machines. And there is a class in Java which is called the inet address, which helps, this class allows us to specify the IP address of the machines, either in this kind of the complete 32-bit address, physical address, or in terms of this kind of logical name, terms of logical names. So therefore, then now next the question comes. So this is when we talk about TCP/IP socket, these type of sockets are used to implement, essentially they follow the TCP/IP type of communication protocol, and it is used to implement reliable point-to-point stream-based connections between programs. So this is what we will see, that how the stream-based connections help. So therefore, we can use some sort of our standard procedure that we have earlier seen, like say the println, or this type of the way that we can read the data or write into the socket directly in the form of a stream. And so therefore, and then between the program, these two may reside on the local host, local machine, or on the internet. And in this case of an internet, the address will be specified either in this kind of a full IP address, which is physical address, or in terms of its logical names like yahoo.com or iitkgp.rnet.in. Now, as far as the TCP/IP sockets are concerned, TCP socket supports two kinds of TCP sockets, one for clients, another for servers. In case of a client, This specify the constructors are, that is string socket, string host name, int port. It creates a socket connecting a local host to the designated host. This designated host name, which is the name of the host, and the port. Or we can give the address in terms of, as I said, both the socket, in this case host name is a machine which is in the which is a local host, and this host name is another machine, or for which the address is known in fact, and it is the port, which port which connects. For instance, in this case, in the more general one, which is uses the INET address object, this is more common. In this case, the address, this IP address, it can be any of the IP address. That is, I can specify socket, and then IP address can be where I can assign to. If I say that IP address is, can be, we can assign it to something like IIT kgp.rnet.in. So this can be our type of address, or we can give the full address. This INET, this class INET address will allow us to specify the address both as a simple domain name, or in terms of its physical address, and that we will see later on when we'll take more examples of this class. Aside from that, this client construct socket, the Java socket class also supports for the servers another type of the constructor which we call the server socket, in which it creates a server socket with specified port having a default queue length of 80, or we can specify the maximum queue length. The idea here is that when the server is listening to the socket, there may be more than one client is trying to communicate to the same socket, to the same server through the same socket, in which case all these requests that are coming from the client will be kept in a queue, and if you do not specify the queue length, some default value will be taken, and if the requests more than the number, the maximum length of the queue is received, these connections will be refused. So the maximum queue will allow us to specify how many waiting connections can be there on the socket for the server program. The method accept, as we had seen our diagram, essentially forces the server to wait to client for initiate communication. Like here in this the diagram, we had seen that the socket, first of all you create a socket, bind the socket, and then server listens to the socket, and it will use the accept call. Now this accept call will force the server to wait, to go into the waiting state till there is a client which tries to communicate through it. The other methods that are supported in the socket class are something like this. For instance, methods supported by iSocket class are get iPort, get the remote port number to which the socket is connected to, get the local port number, INET address, to which is the INET address associated with the socket, and similarly get inputs. Get input stream read, that get input stream returns the input stream associated with the socket. Similarly, get output stream will allow us to get what is the output streams attached to the socket. And finally, there is a class called the call called void close, which closes both the input and output stream. So what we are seeing, therefore, that in a Java we have a fairly good facilities to, first of all, to create sockets. For TCP/IP sockets we are talking first, in which case we will be able to create client sockets using the socket constructors, where the sockets can be in the local machine or in a distant machine, and these machines are basically, in case of an internet address, the address will be specified using the INET address, and the port. So all these client sockets, the TCP/IP sockets requires a port through which the communication will be specified. Similarly, for servers, we have seen there is a constructor called which allows us to construct creates a server socket and with the specified port number. Along with it, we can specify the queue length, and the other methods, as we have mentioned, are to get the port number of a socket, which can be later on used, or what are the INET addresses and so on. So now let us see how these three ideas, the two ideas rather, one the concept of socket and the other the concept of thread, can be used to implement a client server communication using Java. So what I will do, we'll take a very simple example in which there will be the server will receive the request from the client, and then will create a thread, and in which it will serve the request of the client, and when this request is served, it will send back the result to the client. So let's take the very simple code. This is what we call my server Java, and in this case this is a server that uses a multi-threading, as I have already said, to handle any number of clients, and we need the package java.net package, because here in order to support the class socket. And here let's take the very simple thread. What we are seeing, that this thread is supposed to do the servicing of the client's request, and here we define this class service on one client, that this thread, in this thread we go on serving requests of one client at a time, and then we look at the server, where the server will invoke this client and then will go back and then go on continuing with his own job or listening to the socket. And in this case the server object, as we will see later on, the idea of the server would be that which we will define shortly, will have a port which is an 8080, so let us we define arbitrarily, and it has a internal variable called stock, which is the amount available. And what we can see, that the client, we can say this is the amount available, and we can say this is a server is a sort of inventory manager, and it has a stock of a certain item, and the clients are asking for some amount of the items to be issued to it. So what it will be happening, that as the clients will send a request for to get certain amount of the items, so that item will have to be that much items will be given to the client from its existing stock, and then and the process should go on. And the one thing that we should also remember, since this is the stock is basically a shared data, and if you remember in the last class we talked about that whenever there is a shared data, we have to ensure that when there are multiple requests are coming, we should appropriately synchronize it. And so therefore in the server class we will use the synchronize method to control the access of the to have control access to the shared data item. So before we go to the thread, let us look at the class server. So here we are defining a port, which is a port is 8080, and there is an internal variable, as I said, that is a stock. This is private, and then this main program in the server is this public static void main, and in which the stock is, say, let us say initialized arbitrarily to 1000. Now here you see, if you remember, we have considered, we create a server socket, which is the new server socket port. So it creates a server socket in the current machine, and since we are not talking about internet address, so therefore this is in the same machines we are working on, and this is the port is the 8080. So then in this machine we will create a port 8080 and a socket S with bound to that port, and then we say that the server has started. And after that, if you look at this, that is where the same thing we are doing. Then after that, it will use an accept call. On a mind it, we have mentioned whenever it issues an accept call, the server will be blocked until a client makes a request. So what we will do now, we will say that socket S accept. So block, this will make through blocks until a connection occurs in this socket, which the server was connected to, the server socket. And after this, now when such a connection do happen, that is when a client has sent a request, what will the server will doing? A server that uses multi-threading then will handle, in this example, now what we will be doing, it will, I will discuss about the client server, this thread execution little later. So the server is now listening to the socket for the client's request. So now suppose the client has established a connection, what happens? Then the server should receive the request and then process it and send the result back. And what it will be doing, which we will be doing, we will try to, whenever such a connection established, we will initiate a thread, which is the thread we just mentioned before, and in that thread we will do this kind of jobs. So therefore my server will be doing what is that it creates an instance of this class, that is the server1 client socket in that socket, and giving the socket as a parameter, and then if there is an exception, close the socket, otherwise thread will close it, and finished. So therefore what is happening, server, in the moment a request is received, it's no longer blocked, it initiates a thread and asks that thread to go on executing the request from the client, and then the thread will then, when the communication, the execution is over of the thread, before that the thread will send the result back to the client. So let's see that now, therefore, what the thread is really doing. So here is the definition class of thread. Here class server1 clients extends thread, and then this is, it has a couple of internal variable parameters. These are called the sockets. One is of the type socket, that is private socket, and there are two input streams, and now one input stream and one output stream, which is the in and out. And this is the constructor server1 client socket, and then in this case what it does, it just copies the socket information here, and then it generates an input, it initiates an inputs, it creates a socket get input stream and output stream. Both of them will be associated with these two internal variables in and out, and then it starts the run method of the thread. That if you may recall that whenever we have a thread, because the original thread class, the run method in thread class does not do anything, we either have to use a runnable approach, or we can extend the run method inside the inside the subclass, and in this case my subclass is server1 client, and so whenever after the constructor this starts or takes place, it will execute the run method. And what the run does? Now the run does is that it receives it creates two variables, that is data input stream and P out. Now these two are basically the new data input stream of the in, which we have already bound to the, which is bound to the input stream of the socket, and similarly the out, which is connector, which is associated with the get output stream of the socket. So therefore whenever I perform a read, then I will be basically reading from the socket, and similarly when I out through P out, which I print something, that will be communicated through the output stream of the socket. So so therefore now what is happening, try while true, this goes on doing it, string strdin read line. So basically it will be reading one line of the request from the client, which is essentially connected to the socket, because otherwise we could not have come, the server would not have would have still be waiting and would not have so here is when the server was called this, already that through that socket the client was connected to. So therefore here we will be receiving the request from the client, and this is simply printed, and then and I'm echoing back the result back to the client, and then if we check if this is a buy, or say we can say this is get or issue, whatever be the case, then you read the D in the, that means how much amount of, so client is supposed to send a request like say I want to issue or buy this amount of stock items, and therefore so use the keyword buy and followed by the request of the how many items, say 10 or 15. So the first data the client sends is buy, which is checked if it is buy, then you read the amount which will be required, and so this is the string, q string will give you the quantity. This one is required in order, since we are reading in a character basically this is a string from which we need to convert it to an integer appropriate value, and then it's simply printing it, and then my server update quantity. This is a method which is defined in a my server class. As I said that in my server class the stock is essentially shared, and we have to have a synchronized method to do it, and I'll discuss, just we'll bring back the code right now. But before that, what is happening, it calls this update method of the server, which will essentially reduce the stock amount by quantity, and then basically it prints out that this is the then prints the result back, sends the result back to the client. So therefore in this example the whatever the amount the client has requested, that amount will be deducted from the stock, and the client will be informed through the payout print line command. Now let us look back to the update command in the server. This is defined in the server class. In the server class, see we had here, then this is a method in the server class, and in which you see, look here, we are doing a synchronized method. So therefore in this class, which is an integer quantity, what it is doing, it is subtracting the stock minus quantity. Now if you remember this as synchronized methods, only one thread will be allowed to access it at a time, and so the stock in this portion, other threads no other thread will be allowed to access this stock, and therefore the correct amount will be, the integrity of the data will be preserved. And once the stock has been reduced, then print line and stock, and then we ask that let us wait for for some amount of time, that is with this which forces that t dot slip forces that this amount of millisecond, that is to be 10 seconds to wait for another client's request to be communicated. So we are assuming that the clients are if any requests come for the client from another client within this period, it has to wait in the queue, which is the in our declaration we have only given we have created a socket without any queue length, so only the default queue lengths will be allowed, the rest will be rejected. And finally it is when it comes out of it, this data will be again released for another thread to perform operations. So this is how essentially we are allowing through another thread the client's requests are being handled. Now let us look from the client side. If you remember, in the client side what we did, the client again has to connect to a socket, has to have a socket, and then after that it is, once a client establishes a connection to a server, and once a connection is established, it will send the data request and then receive the result from the server. So the following the same approach, let's see what is my client. In this case my client, which is trying to communicate to my server, is first of all, in this case it gets the address of the server. It has to have the address of the server, so we are assuming in this case the server is in the same machine, and then it prints that, and after that it declares certain local variables C, string and string2, and then there is a socket. Then it creates two in the input and one input stream, which is the in data, which is new data input stream with system in, and then from which essentially it reads the request from the client, actual client, through his standard input devices. Say for instance we can say that buy 40 or 560. So client program gets the user's request through in data, and it will then communicate this one to the server. Then it creates, you see here, it creates a socket, and this socket has the address which is the server's address followed by the server port, my server dot port, and in this case my server dot port is 80. So it will create a socket and will bind to the same port. After this, it will go on trying to send, that is the once this is it is trying to establish a connection, it will have to send the data. So what it does, first of all, it is simply the socket, which socket it is connected to, and after that is a input stream is a socket get input stream. So it is now, so the in will be connected to the input stream of the socket, and outstream will be connected to the outstream of the socket. And data input stream is DIN, which is new data input stream IN, and it creates a print output stream, print stream, which is P out. So both of these are created, which will essentially will be having this one, they will connect, will be to receive the data from the socket, as well as to send the data through the socket at the client side. The same thing we had done in the case of in the server side. And after that, so therefore in the program, first of all, it reads the data in data read line. It reads the data from the using the read line, and after that P out print line str. So it prints the P out print line. That means this same data which has been read, say by let's say the by 60 amounts, then this one will be put P out. So now this P out will be connected to the output stream of the socket, and so therefore this will be essentially the sent, this data what the socket has the client has read from the user, the client program has read from the user, will be sent through the P out, which is connected. P out is the print stream of the out, and out is the connected to the data stream output stream of the socket. So it will be sent through the socket, and this socket with the other side client server is listening, server can then read what is being sent and then take appropriate action. And after that, here the next part is that what the server is send the data, it has to be read by the client, and this part what it is done in this case is that we are reading whatever the server has sent into the string 2. You want to do it, and this is D in read line. D in is, again you can see, is the input, is essentially the input stream is of type input stream, which is the socket dot get input stream. So whatever is written into the socket's input stream will be stored into the string 2, and then I can use simply just printing the string 2 data, and this will go on till string equals end. So after this, that is the client. What the client is essentially doing, it's creating a socket which is binding the one, this it is connecting to the socket of the server, and then goes on listening to that. That is sending the, first of all, sends a request to the socket at this point, and then when the data is being processed by this being processed by the server, it receives the data through the same socket and then prints the same. So therefore, what we have seen that this is a typical connection oriented protocol in which the server we have given this we have illustrated that the server essentially processing the request of the client in another thread. And the advantage here is that we can also we can allow the server to listen to multiple clients till even though it is in another thread, it is processing the request of an existing client. Now this type of approach, that's why this thread concept is very much intimately related to the concept to the and rather useful in implementing client server communication in Java. And we can, in fact, this example which you have taken is rather very simple, and however we can write more complicated servers if you like, and that should be taken up in your laboratory exercises. In the next lecture, what we will do, we'll look at a little bit another type of servers which we call the datagram oriented servers, and datagram oriented sockets, which essentially will implement the UDP protocol, and also we'll see that how in that environment also we can establish implement the client server communication.